The basic James Webb Space Telescope, JWST, marks a fundamental second in humankind's outing to uncover the mysteries of the universe. This fundamental observatory, named to respect James Webb, a fundamental figure in NASA's set of experiences, addresses the finish of different huge stretches of logical headway and overall cooperation. As mankind's most progressive space telescope to date, the JWST vows to change how we might interpret the universe and reclassify the limits of astrophysical research. Situated at the second Lagrange point, L2, around 1.5 million kilometers from Earth, the JWST offers an unmatched viewpoint on the universe. Not at all like its ancestor, the Hubble Space Telescope, HST, which circled Earth, the JWST's area guarantees a steady and unhindered perspective on the universe, liberated from the twists brought about by Earth's environment. This fundamental situating permits the JWST to dive profound into space, catching even the slightest signs from the most far-off heavenly objects. Equipped with a scope of cutting-edge instruments, the JWST flaunts unrivaled capacities for noticing the universe across various frequencies, from close infrared to mid-infrared. Its essential mirror, comprised of 18 hexagonal sections covered in gold, ranges a noteworthy 6.5 meters in measurement, giving extraordinary light social event power. Joined with best-in-class infrared locators and spectrographs, the JWST can identify the slightest flickers from far-off universes, stars, and exoplanets. One of the JWST's essential objectives is to concentrate on the arrangement and development of worlds all through enormous history. By looking billions of years into the past, the telescope can catch light from the earliest systems, offering experiences into the cycles that prompted the arrangement of the immense designs we notice today. Besides, the JWST's perspective on neighboring frameworks gives significant information on star arrangement rates, heavenly masses, and the dissemination of dim matter, revealing insight into the critical drivers of world growth. Beyond its investigation of universes, the JWST is ready to upset how we might interpret exoplanets, planets circling stars outside our planetary group. With its better awareness than infrared radiation, the telescope can test the airs of exoplanets, looking for indications of water, methane, and different atoms that could show the presence of life. By performing transmission spectroscopy, which includes dissecting a planet's environment as it passes before its host star, the JWST expects to distinguish possibly livable universes and explore planetary diversity. Additionally, the JWST's perceptions of our own nearby planet group give new bits of knowledge into the creation of planets, moons, and other divine bodies. By zeroing in on the environments of planets like Jupiter, Saturn, and Mars, the telescope offers basic data on barometrical organization, environment conditions, and surface highlights. Also, the JWST's perceptions of space rocks, comets, and other little bodies upgrade how we might interpret nearby planet group arrangement and the starting points of planetary systems. Beyond its logical goals, the JWST exemplifies the soul of worldwide participation and cooperative exertion. Coming about because of an organization between NASA, the European Space Organization, ESA, and the Canadian Space Organization, CSA, the telescope addresses an aggregate obligation to propelling human information and exploration. By pooling assets, mastery, and mechanical capacities, the JWST project epitomizes the force of worldwide coordinated effort in resolving huge inquiries regarding our spot in the universe. As the JWST leaves on its excursion of revelation, it conveys with it the expectations and desires of endless researchers, architects, and space lovers around the world. Each new finding and weighty disclosure extends the skylines of human information and moves people in the future to investigate the miracles of the universe. From unwinding the secrets of system development to looking for indications of extraterrestrial life, the JWST vows to be a reference point of logical headway and a demonstration of mankind's unlimited curiosity. This remarkable revelation and investigation of room have consistently extended our grip of the universe, and presently we stand nearer than at any other time to accomplishing this basic objective, because of the James Webb Space Telescope. The telescope's sharp pictures of far-off cosmic systems are reshaping how we might interpret the universe in significant ways. Plan for an exceptional time that started on December 25, 2021, when the JWST sent off from the Guiana Space Center. This state-of-the-art observatory, a cooperative exertion including NASA, ESA, and CSA, respects James Webb and adds another part to NASA's tradition of investigation. The primary parts of the JWST program follow back to NASA's rich history of room research, expanding on the accomplishments of past missions like the Hubble Space Telescope, HST, sent off in 1990. The HST, a symbol of mankind's journey to comprehend the universe, gave pivotal experiences and laid the basis for the aggressive JWST mission. The HST was intended to conquer the limits forced by Earth's climate, circling in low Earth circle around 340 kilometers over the surface. It utilized progressed reflect innovation and accuracy instruments to catch and examine light from divine articles with wonderful lucidity. All through its main goal, the HST caught dazzling pictures and gave fundamental logical information, essentially adding to how we might interpret the universe. Its prominent accomplishments incorporate uncovering tremendous measures of vast designs in apparently void space, displaying star development in the mainstays of creation, and uncovering the super-profound field, uncovering systems as far back as the early universe. The HST likewise assumed a pivotal part in finding exoplanets, noticing grandiose effects, and affirming key cosmological speculations, like the enormous detonation. By zeroing in on far-off worlds and grandiose foundation radiation, the HST gave authoritative proof supporting the hypothesis of the universe's starting point and added to estimating the pace of enormous extension through redshift observations. Now, with the JWST identifying light from one more system 7 trillion miles away, the splendor of astronomical investigation is being restored. As we dive into the ramifications of this amazing revelation, we proceed with the practice of disentangling the secrets of the universe. The information accumulated has uncovered an interesting part of our universe. Systems farther away are withdrawing from us at higher rates, affirming the extension we had expected. The Hubble Space Telescope assumed a basic part in refining how we might interpret this development, especially through the Hubble study, which estimates the rate at which the universe is still up in the air by cosmologist Edwin Hubble during the 1920s. Ensuing perceptions from Hubble refined this study, albeit ongoing estimations have prompted some discrepancies. These experiences, alongside staggering pictures, have extended our cosmic information past what Hubble could give. NASA's presentation of the James Webb Space Telescope addresses a great accomplishment in space research. NASA's broad endeavors, from Mars Meanderer missions to Explorer missions, added to the innovative progressions vital for the JWST's development. The send-off of the JWST carries us nearer to grasping the nature, beginnings, and destiny of the universe. Dissimilar to its ancestor, the JWST catches long-frequency infrared light, giving a more extensive and more clear galactic view. One more huge disclosure by the JWST incorporates distinguishing light from a planet 7 trillion miles away, testing existing speculations. This finding recommends that the planet WASP 96b could hold onto extraterrestrial life, igniting energy and interest in the chance of outsider life past our planetary group. This revelation, at such an unimaginable distance, features the JWST's exceptional observational capabilities. Designed to outperform Hubble, the JWST can look through vast residue mists, uncovering stowed-away enormous peculiarities. With a 6.5-meter essential mirror made of gold-plated beryllium fragments, high-level infrared cameras, and a front-line sunshield, the JWST works at an uncommonly cool temperature, fundamental for its infrared perceptions. With its predominant capacities and high-level instruments, the JWST outperforms past observatories, improving our capacity to investigate the universe. One of its essential objectives is to zero in on the climates of exoplanets, looking for indications of livability and key particles like water and methane. By analyzing radiation from immense distances, the JWST likewise thinks back in time, catching light from antiquated worlds, stars, and vast designs framed billions of years prior, unwinding the universe's beginnings and evolution. Beyond our planetary group, the JWST mission stretches out to concentrating on the elements of grandiose development, including the noticeable universe's extension. The telescope has made critical revelations, reshaping how we might interpret the universe. Among these is the striking picture of Stepan's Quintet, a gathering of 5 universes around 290 million light-years away, where 4 worlds cooperate in a gigantic enormous dance, uncovering gravitational collaborations and impacts. These perceptions give bits of knowledge into world development, star arrangement, and the strange idea of dull matter. The JWST likewise caught an itemized picture of the Carina Cloud, a star framing district around 7,600 light-years away, including gas, residue, and star nurseries, featuring the development of new stars, including estimated time of arrival Carina, a twofold star framework with an interesting history. The JWST's new picture offers unmatched clearness, supporting the investigation of star development and nebular structure. The perception of the southern ring cloud, otherwise called the hourglass cloud, situated around 2,500 light-years away, uncovered the second star in